Hello and welcome to this tutorial. My name is Masoud and today I just want to take a quick look at this Linksys WRT 3200 ACM router. So a couple of weeks ago I bought this one and I played with it a little bit, and now I just want to share some information with you guys. So as you can see, this router is a game changer. If you take a look at the configuration specification for this router, you can see that this beast, it has actually a CPU of 1.8 gigahertz. It's a dual core CPU and 512 megabyte of RAM, and also 256 flash memory, and it has 4 Ethernet ports on the back, and one of them is for internet connectivity. And also it has eSATA and the USB port that you can use it for storage, like an external hard disk or a USB stick, and you can use it for as a NAS storage in your environment. So what I did, actually, I bought this router, and one of the advantages of WRT series of the Linksys is you can install an open source firmware on top of this hardware. So what I did, I actually installed a DD-WRT firmware on the top of this hardware, which is pretty easy. You can just go to the website and you can search your model in a database, and you can download it, and you can just install it on top of the default firmware of the Linksys. You can go and you can just select the firmware, and you can upload it to the router and start upgrading. But yeah, I mean, the only important note is that you have to make sure that you're connected through a cable, not through the wireless, when you're doing this upgrade. And I did this. And now I want to share some settings with you, and this is actually after putting the DD-WRT on the top of the router. This is the interface that you can see. So I access through my router to the IP address, and I already put my username and password, and this is the settings that you can see. This is the router model. It's a Linksys WRT 3200 ACM, and I put the DWRT firmware on top of this hardware. So I'm going right away through the wireless configuration to show you some settings, and I go to the wireless tab here. As you can see, by default you have 3 interfaces. One of them is ATH0, and I'm talking about wireless. Look, I'm in the wireless and I'm in the basic settings. So first one is ATH0, and it's a wireless physical interface, ATH0 5 gigahertz. And the second one is ATH1, which is 2.4, which it makes sense for most of us, and we have 5 gigahertz and we have 2.4 gigahertz. But if you scroll down, you're seeing another one which is called ATH2, which is 2.4 and also 5 gigahertz. So the first tip for you guys is you have to disable this one, and we are not going to use this one. It's actually useless. We don't use this one, so make sure that you're disabling this one. And another one is, so I play with this one a lot with these settings, so I start changing all of them, trying to use different softwares. I use Wi-Fi analyzer on a Windows 10 machine, and also I used Wi-Fi analyzer on an Android device to see how would be the strength of the signals through different rooms and different floors. And I actually start changing all of them. I changed the channel width to VHT 80 megahertz and start testing from different rooms. Also, I went through the advanced settings here and start playing with the text power. I changed this one to different numbers, to 40, to 45, to 100 even, to see how would be the signal coverage. Another thing that I start playing with it was this protection mode. I changed it to RTS and CTS and different settings. At the end of the day, with multiple testings and multiple environments, this is the result that I got. So my suggestion to you is put a wireless, put an SSID for 5 gigahertz and a different SSID for 2.4. So you can set the same SSID for them, then it's gonna be up to the client to choose which one it can access. But you know what? In my case, because I'm living in third story building, so in my case it was better to distinguish between 2.4 and 5 gigahertz, because I can, if my device doesn't need that much throughput, then I can just connect it to 2.4, and it's easier and it has more coverage. And but in your case it may be different. But another thing is I mean, playing with takes power could be useful. I mean, setting it to 45 or 50, but when I increased it to 100, it was actually less coverage. And another thing that I changed here is in 2.4 actually. So if I go to advanced settings, the change here was I was playing with this takes power also. So when I increased this one to 100, it was actually more coverage from 2.4. Again, don't play with the antenna gain and other settings. It's useless, it's not working properly. And the only useful part was this takes power a little bit. And another thing is some people are saying, okay, go to the wireless channel and start changing these channels. Well, you can try with Wi-Fi scanners to see which channel is more free and it's not that much occupied. But in my case, even the auto one was better. And in 2.4 you have less channels, but in 5 gigahertz you have a lot of channels here. And I'll even try to fix it to 149, 144 because in my Wi-Fi analyzer the bandwidth was really better. But at the end of the day, again, wasn't really useful. So my suggestion, in just for a recap, is some people actually they're suggesting that you can go ahead and change this one to VHT 80 megahertz, and you can fix your wireless channel to a number, let's say 149. And another setting is that you can start increasing the takes power. Let's say I'm putting it to 100. So make sure that your router is in a cool room. I mean, it's gonna be the room is not really cool. So another thing is that if you're seeing the Wi-Fi disconnectivity, you can also start changing this one, the protection mode, to RTS CTS to see how would be the result. But again, this is just up to you and your environment and how is your building, for example.